Hey, we're Team 26 and we've been working on HDMI output for the Pi. So our motivation for this project was trying to make the Pi more of a standalone device. Currently, our operating system really relies on the UART in our computer for both input and output. We hope to change that and move beyond that. The biggest challenge we faced during this was finding any sort of documentation. There really isn't much out there, so we've had to kind of piece together bits and pieces. And we hope to show through our demo how our concept of the HDMI and frame buffer evolved. To output to the HDMI, you need to set up a frame buffer. To set this frame buffer up, you need to communicate from the CPU to the GPU. How this is done on the Pi is through a system called mailboxes. So to get this information from the GPU, you need to allocate space on the heap where you place certain tags for the properties you want, and then fill these tags with certain info that you're requesting from the GPU, pass the pointer to this space into the mailbox, where then you wait for the response. The GPU will then read this pointer from the mailbox, do work on the space, and then return the same pointer, in which you will read it, get the information that the GPU has provided, and then create the frame buffer from that. You can now place the data you want to transmit into that frame buffer.
There are very few resources that the Raspberry Pi Foundation puts out about the firmware. Specifically regarding the HDMI resource, they don't have anything that they describe about it. They have a page on their website, but it doesn't show much. So we had to do some digging. We found this mailbox property interface, which is a GitHub link that the Raspberry Pi Foundation does put out, but it's very, very slim and is not fully fleshed out in the slightest. So we had to go through a variety of trial and error and checking other people's code to find what worked for us. But after we did go and through that process, we ended up getting the code to run. We got a frame buffer allocated by the GPU, which was a huge plus for us. We thought that we were very lucky. And finally, when it was fully fleshed out, we were able to produce this color splashing, where we basically just iterated through a variety of different colors on the screen as our first test to make sure that the frame buffer worked as we thought and it was correct. And miraculously, it was.
The frame buffer is a buffer allocated that represents the HDMI device's screen. It is a one-dimensional array of 32-bit pixel values, and this is obtained through a request to a mailbox register, and we explained the functionality of those previously. So we actually input a request for a certain buffer size and the size of each pixel value, and then we receive a raw pointer in return. Which we can then write to display values to the HDMI screen. With that raw pointer, we actually created a slice so that we can safely write to and read from the slice without any unsafe code.
So right now we have a default screen for the Raspberry Pi. This comes on anytime you turn on the Raspberry Pi. So what we're going to be doing is showing that we change the default screen. Currently we have the shell actually loaded there's an interrupt between the console layer, so we can write anything that we put into the UART onto the screen. So we have to transmit this, which is going to take 30 seconds. And in the meantime, I'm going to sit here. This is the shell. Clearly it's on the screen. Hopefully we'll have a way to cut this in as well using the recorded video, but if not, this is me typing echo hello. I'll even add a world in there. The little dot over here is a new line, which just shows that it's a new line. In addition to this, we have, let's see, I can clear the screen, which I believe is, we can also do backspace. Clear? Yeah, perfect. And then it just clears the screen and starts everything over. Yeah, so we managed to port the entire shell onto HDMI. This works even if I'm not connected to the UART. So if I unplug this, so my UART is no longer connected, I still have an interface. You can't type onto it, but because you still need the UART for that. But hopefully we'll be able to add on some sort of keyboard input or some sort of external input. Thank you. So the current product that we have is an HDMI library, which contains both the mailbox code and the frame buffer code. The mailbox code simply allows us to access any of the mailboxes, and the frame buffer code is what the global frame buffer ends up using to create and instantiate a frame buffer, as well as get the raw pointer information so that it can create a safe access into it. We also created a global character buffer, which ports any of the inputs that we get from the UART into a global array, which we can access from the global frame buffer and port directly to a screen, which is how we write the shellcode. So in addition to the shellcode, we also have a simple interface for drawing shapes. It's not very fleshed out yet, that's why we didn't include it, but we want to work on that a lot more, which we talk about later. And this concept of drawing shapes is what we hope will lead us into building a GUI. We'll talk more about that on the next slide.
We have a few improvements that we'd like to add to this project moving forward before the end of the semester. The first of which is to implement code to read the EDID from the HDMI device using a mailbox register call. And that would return the size of the HDMI device screen that we are interacting with, meaning that we can dynamically size the frame buffer that we are allocating. We would also like to complete the basic shape manipulation that we have started already. And finally, we'd like to have a more thoroughly implemented version of the shell through HDMI.
As said, we've wanted to create a more standalone device. So on that line of thinking, we have also been looking into adding some sort of external input, whether that be a keyboard or through the Wi-Fi card or something else. We also have considered implementing some sort of GUI, either a Windows system or something like that, now that we have HDMI output. Along with this, maybe some sort of GPU acceleration. And then also there is the possibility for outputting audio from the HDMI as well, which is another thing we are considering.
So once again, we are Team 26. This has been our demo of an HDMI device driver for the Raspberry Pi and the Rust OS operating system. Please let us know what you think.